Everyone, welcome once again to this online chemistry class. So we are continuing with this chapter, carbon and its compounds. In the previous class we had learnt about covalent bonding and how carbon helps in forming covalent compounds. What is covalent bonding? When there is sharing of electrons, there is no transfer of electrons. When electrons are shared, we call it as covalent bonding. Okay, now in today's session we'll learn about the versatile nature of carbon and what makes carbon versatile in nature. There are two main properties which makes carbon show this property of versatility. What are those properties? One is catenation and another one is it is tetravalent. What is versatile in nature? What do you mean by the word versatile? Ability to adapt itself. So this carbon, because of the property possessed by it, that is catenation and it is tetravalent in nature, makes it a versatile element. Okay, so now what is catenation? This carbon can form long chains with other carbon atoms. It can link itself with other carbon atoms, forming long chains. These chains can be straight in pattern, they can be branched, they can be ring like in structure. Those things we'll study in detail. So what is catenation? It is a property of an element by virtue of which there is self-linking of atoms covalently. Covalently means what? Sharing of electrons to form strong chains. And these can be straight chains, branch chains or ring structures. Okay, so carbon has the unique ability to form bonds with other atoms of carbon, giving rise to large molecules. So no other element exhibits this property of catenation to the extent as seen in carbon compounds. Okay, next, see, these are the examples for you to understand the property of catenation. The first example, a very long chain is formed. So it can be linked with hydrogen atom, right, or oxygen atom, depends on the compound that it is going to form. Branch chain, closed chain, examples are given. These structures we will learn in detail. Okay, so this self-linking property of carbon to form long chains is what is called as catenation. And next, it is tetravalent, means what? Carbon has valency 4. It can share 4 electrons with atoms of carbon or with atoms of other elements. Okay, so it is capable of bonding with 4 other atoms of carbon or atoms of some other monovalent element. Mostly carbon can form compounds with hydrogen, oxygen, nitrogen, sulfur, chlorine and many other elements. Okay, so these two properties of carbon makes it versatile in nature. One is catenation and another one is tetravalent. What is catenation? Forming long chains. Self-linking property. Carbon can form covalent bond with other carbon atoms and with atoms of other elements. In that case it can form long chains. So many compounds are formed by the help of carbon. Okay, this unique property is not seen to that extent as what is seen in carbon. Other elements do form, but the extent to which carbon forms is much more when compared to other elements. Next is tetravalent, means it has got valency 4. So this 4 electrons which is present in the outermost shell of carbon atom can share electrons with other carbon atoms or with atoms of some other element. These two properties makes carbon versatile in nature. So organic compounds are generally hydrocarbons containing carbon and hydrogen atoms linked by covalent bonds, right? And these hydrocarbons can otherwise be defined as organic compounds of carbon and hydrogen. And these hydrocarbons are classified as saturated and unsaturated hydrocarbons. So what are saturated hydrocarbons? When hydrocarbons are formed by sharing one electron, a single bond is formed there. Such hydrocarbons are said to be saturated hydrocarbons. I've given the dot structure of methane here. This we have seen in the previous class also. So here carbon has 4 electrons in its outermost shell. Those 4 electrons are shared with 4 hydrogen atom because hydrogen also has 1 electron in its outermost shell. So this hydrocarbon here formed here is methane, which is represented as CH 4, right? Carbon and hydrogen here, so it's a hydrocarbon. So when one electron is shared, a single bond is formed there. It's like this, right? So when I represent the same like this, carbon linked with 4 hydrogen atom, this is the structural representation of methane, right? A single bond is shown everywhere, see, a single bond. Carbon, you remember like this, carbon has 4 hands. So every hand is connected with 1 hydrogen atom. So this is the structural representation of hydrocarbon methane. Okay, now see the dot structure of ethane, right? So now what happens here? Let me write the structural representation of ethane. See, carbon, it has got 4 hands, right? Now in ethane there are 2 carbon atoms. So this carbon again has 4 hands, right? So now every hand is connected with 1 hydrogen. So I'll write the formula as C2H6. So this is the structural representation. Everywhere a single bond is formed, 1 electron is shared. So this ethane is also a saturated hydrocarbons. You can say that the compounds that end with A and E, methane, ethane, propane, butane ending with A and E, these are all saturated hydrocarbons which shares 1 electron each with hydrogen atoms, right? Now when a single bond is formed, we call it as saturated hydrocarbon. So now let's learn about unsaturated hydrocarbons. So organic compounds in which either a double bond or a triple bond is present between 2 carbon atoms, they are said to be unsaturated hydrocarbons. A double bond or a triple bond is formed between 2 carbon atoms. Or in other words, you can easily say if the hydrocarbons that end with ENE or YNE, okay, they are coming under the category of unsaturated hydrocarbons. For example, let's take ethene. See, can you see in the figure given here 2 carbon atoms, okay, connected by a double bond. So each carbon atom has shared one of its hand. How many hands are left? 2 hands for this carbon atom, the 2 hands for this carbon atom. So when it is shared with hydrogen atom, this is the structural representation for ethene, right, whose formula will be C2H4. Same way I have given the structural representation of ethyne, where a triple bond is formed between 2 carbon atoms. So between 2 carbon atoms, 3 hands are shared. How many hands are left now for each carbon atom? 1 hand. That is shared between 2 hydrogen with 2 hydrogen atoms. So it is ethyne. So when when these hydrocarbons have names ending with ENE or YNE, they are all unsaturated hydrocarbons which are formed by either a double bond or a triple bond. Here you can see in ethene a double bond and in ethyne a triple bond. Clear to you? So with this we have come to an end of today's session. So in today's session we had seen the versatile nature of carbon. Why is carbon so versatile in nature? Because it has the ability to form long chains, which is called as catenation, and it is tetravalent, sharing of electrons. The outermost 4 electrons are shared with atoms of carbon or with atoms of some other element. These two properties are so unique that it makes it versatile in nature. And then we had discussed about saturated and unsaturated hydrocarbons. So with this we are coming to an end of today's session. Meet you soon in the next session. Take care. Goodbye. Have a nice day.